Hey, Algebra 2. I hope you had a wonderful break and you're ready to dive right into school again. I know I am. It was a great break. I got to see some of my family and little pieces. We didn't have the big parties, obviously, but it was nice to see everyone. And I'm really happy to be back. We did start with an exploration right before break. Remember on the parabola. Okay, that's what this is, an upside down parabola, right? But we talked about I wanted you to see how they compare to absolute value equations. Okay, so we are starting our unit 4 formally now. We did the exploration because we had just had our unit 3 test, and I just wanted to introduce it, but now we're actually starting with some notes. Okay, we're talking about how do you graph a quadratic function in vertex form. Okay, so we know what the vertex is. It's very similar to when we did absolute value equations. It's where right here, kind of where the graph V's, where it changes from decreasing to increasing. The same with the parabola, right? So you're watching this video right now, so I'm not going to have you do this part. This is what we'll be doing. We did in class if you missed it. I had them talk about similarities and differences. But looking at the two graphs, the similarities, they have a vertex, both of them. They're, this is y equals x squared. Everything's positive, just like y equals absolute value of x. Everything is positive except here at 0, 0. The differences are, this is linear. The increase is happening in a linear fashion, where here, we're squaring x. Okay, the square of 1 is 1. The square of 2 is 4. By 3, I'm already up to 9. Here at 3, I'm only at 3 because it's just y equals absolute value of x. Okay, so it has a different shape. It's not a V. It's called a parabola. Some people call it a U shape. Okay, but it's called a parabola. All right, let's look at your Socrative results just to have an idea. You guys did a pretty good job. I had asked you to write the equations of these or match the equations, right? So here, since the vertex is shifted down to -5, the answer was y equals x squared minus 5. And 75% of you got it right. Some of you, look, you kind of got a little mixed up with where, is the 5 positive or negative? Remember, the y coordinate of the vertex, it will be the same in the equation. So since the y coordinate was -5, we're x squared minus 5. Okay, I also wanted to remind you, if you're not sure, you can graph it. You're welcome to use Desmos anytime, guys. Okay, you can go to Desmos and type in y equals x. You have to use the up arrow, which is kind of right above the 6. You go shift 6, and it'll move up to the exponent, x squared. Then we want to come off of that, so I hit the right arrow at the bottom right of your keyboard. It takes me down, and I'll say minus 5. And there I can see, oh, that shifted it down 5. If I would have said plus 5, oh, that shifted it up 5. I can barely see it. Okay? So please feel free to do that at any time. All right? Okay, well, sorry. Now let's go back to our Socrative results. Here we go. All right, so 75% of you got that one right. This one, let's look. What's the vertex here? The vertex is 0, -5. Almost all of you got that right. Some of you got tricked by these multiple choice. Sometimes they make us think it's something that it's not. Sorry about that. Didn't mean to trick you, but let's, just concentrate. 0, -5. The next one, number 3. Oh, here we went. Let me blow this up a little bit. Okay, so you can see it. Which is the equation of letter G? Well, letter G is just our basic y equals x squared, isn't it? 1, 1, 2, 4. Looks like it would be on there. Okay, it's just y equals x squared. Okay. So, let's see how we did. Oh, 88% of you got it right there too. Yay. Okay. The next one was letter H. Let's see what letter H is. Letter H is over here. So it was moved to the right 4 and up 2. To the right 4 and up 2, right? So this is where we get a little funny with this. It's the same as the absolute value. You might be thinking +4 + 2, but it's actually -4 + 2, which 75% of you got right. Okay. Shifting to the right, just, it ends up being -4 + 2. And again, check it out on Desmos. Okay. Letter H, I shifted to the right 4, which is a -4, and then I shifted up 2, which was +2. Okay. Number 5, 63% of you got this one right. Letter F is over here. Do you notice that letter F is wider? Okay, it was shifted to the left 4 and up 2. So most of you had that it was +4 + 2. Like this person was right about where the vertex was. So that's great. But you forgot that it's a little wider. So that means that's what this number in front does. If it's something less than 1, like a half, 2/3, a fraction less than 1, it's going to be wider than the normal x squared graph. So that's why it was C. Number 6, we wanted to look at letter A, which is upside down. That's our first one that's upside down. So I know there has to be a negative in front. Oh, they all have a negative. It's also shifted down 4. So it should be -x squared -4. Well, a lot of you put that, a couple of you. But then you had to realize, oh, wait, it is wider. Okay, 1 is on the graph. It's wider than the usual one. So that's why it was -1/2 x squared -4. Okay. Number 7 was letter B. Where's letter B? Here we go. So that's shifted to the left 4 and down 2. And that looks, what do you think? That's no wider than that, is it? So I don't have to worry about a number in front, but it's shifted to the left 4 and down 2. So that will be +4 -2. Okay, we didn't need a 2 in front. It wasn't skinnier. A 2 in front would make it skinnier. Number 8 was letter C. That's upside down. Now, does that look skinnier to you? Do you see that when I go down 1 over 1, it's not, it's not on there? So it's a little skinnier and it's negative. Shifted to the left 2, so that's going to be +2. That one was letter A. All right, these were tough. I know. Only about half of you got that one right. Shifted to the left 2 is this +2 inside. Flipped upside down is the negative. The fact that it's skinnier is the 2. Okay? Number 9, we wanted to look at letter D. I can't even find, oh, that's upside down as well, but it's shifted to the right 2. So that one, most of you got that one, shifted to the right 2, upside down, and negative. These two were exactly the same in their width and everything. It's just one was x -2 and one was x +2. Kind of the opposite of what you'd think when we shift horizontally. Letter E. Where are we, E? Is this E? Shifted to the right 4 and down 2. That looks a little skinny, doesn't it? And when I go down 1 and over 1, I'm not on there. So it's skinny, flipped upside down. I went to the right 4 and down 2. That's why that was letter C. Good job. Okay, this person I'm not worried about. All you missed was the 2, the fact that it was skinnier, these couple people. Okay, this person just thinks, oh, shoot, it went to the right 4, so you're thinking, oh, it's +4. Remember, right or left shifts are the opposite of what you think. All right, so that's Desmos. That was your Socrative results. Nice job. Now let's look at taking some formal notes here. Okay, guys. We're going to complete this table and graph this. This might seem silly to you, but we have, let's take our time now and really understand the parabola, even though you have played with it a little bit. I understand. Okay, so Sorry, I'm trying to see how much time I have left here. Let's try this. Okay, let me grab red. Y equals x squared. That means whatever x is, I'm squaring it. -3 squared is +9. -2 squared, -2 times -2, +4. -1 squared, -1 times -1, +1. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So if I graph those, -3, 9, -2, 4, -1, 1, 0, 0. Oh, look at this. On the other side of the vertex, we have the exact same y coordinates. Okay, parabolas, guys, are symmetric. They're the same y coordinates to the left of the vertex as they are to the right. This U shape is called a parabola. I'm sorry that you don't have notes to take this at home. Maybe you can just jot it down on a piece of paper, or you'll always have this video to refer back to. The highest or lowest point on the curve is the vertex. And this is called the parent function, which is regular y equals x squared. It's the parent function before we start shifting it right and left and up and down and flip it. Okay, but this is in this case, it's the smallest. 0 is the smallest that this graph will ever be. Okay, so it's either, the vertex is either going to be the highest or the lowest. If I flip this upside down, it would be the lowest, right? Let me pause this. I just needed to see how much time I had left. The axis of symmetry. This is a new word. Axis of symmetry. Don't get scared by that big long word. The axis of symmetry is just the vertical line that passes through the vertex. Oh, sorry. Pretend like I drew that very straight. This is the axis of symmetry for this parabola. This vertical line cuts the parabola in half. It's kind of how I like to think of it. And the equation of a vertical line, remember, is always x equals something. So this is x equals 0. It's always x equals the x coordinate of the vertex. Okay, the domain, guys, it's always all reals. You can square any number. I'm not dividing by x. I'm not putting x under a square root. The domain of y equals x squared is all reals, no matter what you do to it, okay? The range, however, the y values, do you see that the y values are always positive? So all the y's are going to be greater than or equal to 0 in this case, okay? Depending on where we move it, the range will change, okay? The domain will always be all reals, but you really have to look at the y coordinate of your vertex and look at what kind of y values are coming out. My y values are never going to be negative for y equals x squared, right? It's y is greater than or equal to 0. It's not always going to be y is greater than or equal to 0 because I shift this thing around a lot, okay? Is everybody all right with these notes? Okay, great. Now, we obviously are going to transform this stuff, all right, just like we did with the absolute value. So this is just a reminder of what these letters do. A, H, and K. A, if A is positive, my parabola opens up. If A is negative, it's reflected over the x-axis. In other words, it opens down. If the absolute value of A is greater than 1, in other words, 2, 3, or -2, or -3, it's going to be a narrow, skinny graph. Skinnier, narrower, okay? If A, absolute value of A is less than 1, like a half, -3/4, 2/3, then it's going to be a wider graph, okay? Whether I'm opening up or down, it'll be wider, okay? And you know how the horizontals and vertical shifts work, okay? Look at those. Remember, horizontal is kind of the opposite of what you think. -4 shifts it to the right. Plus H shifts it to the left. I don't know why I said 4. All right, see you at the next video. Please tune in for